Hello, Dr. Machiketa. How are you?
Can you hear me, Saurav?
Yes, I can. How are you?
Okay, it's kind of 8 p.m. here,
Oh,
so little tired.
I can.
How's uh, yeah, I'm sorry I could not attend yesterday because it started at 2 p.m. at your time, which is kind of 3 a.m. in my time.
Yes,
So
yes.
how's that? How's the first session?
Yeah, the first day was really nice. We had a good gathering of scientists and practitioners and also students, operational meteorologists. So we had a very
Awesome.
wonderful day.
So is it like really like is it hybrid or it's in person?
It's
Like
hybrid. It's hybrid. Some we are having some physical and some virtual participations. So anyway, I think our respected session chair, Dr. Milind Mazumdar, has joined us. So although we are waiting for honorable session co-chair, he might take a few minutes to join. Uh, in that regards, shall we begin, Dr. Mujumdar?
Yeah, just there are 2 minutes, I think,
Yeah, I know.
isn't it? Yeah.
I just have
Yes.
to introduce and give it.
Yeah. You can start. You can
Okay.
start. Yes.
Okay.
Yes.
Okay. So then again, welcome from Department of Meteorology, University of Dhaka. So today we are having the second day of our international conference. And starting off the day, we will have technical session 3, engaging youth in climate science. So this is a very shall I say, this is a very prospective session, and we are really looking forward to the presentations. And also, I'd like to introduce the honorable session who'll be giving the first speech also, the session speaker, Dr. Nachiketa Acharya from CRS and NOAA PSL. I think I've got your affiliation correct, right?
yeah, correct.
Ah,
Thanks.
okay. So welcome everyone, and I am handing over the controls to the session moderator, Dr. Majumdar, and hopefully we'll have Dr. Kamal within a very short amount of time. So over to you, sir.
Yes, thank you. Thank you so much. Namaskar ji. Good morning to all. And since yesterday, this conference is going very well. I have attended yesterday's sessions and the discussion and all the presentations. Particularly the discussion I enjoyed much after the presentation. So today we have altogether 7 presentations. Okay. And this is the session title is Engaging Youth in Climate Science. I would have, asked the honorable co-chair also. But what I suggest is, this is since this is engaging youth in climate science, anyone, any youth can do the summary at the end. Actually, I just want to invite. If nobody comes forward, I will definitely do that. But any young researcher to do this summary. So, and the thing is, unfortunately, Dr. Rathod, he is not there, and I may not be able to fill that gap. But since this given opportunity, let me start with. So first presentation is by Dr. Nachiket Acharya, and this is the title is Hybrid Prediction Statistical Dynamical Scheme for Bay of Bengal Cyclone Season Activity. So you have 15 minutes time. So please, Dr. Acharya, please.
Thank you, Dr. Mojumdar, and thank you, Shubho, especially because he gave me a excellent time because yesterday my talk was scheduled, but I cannot be. So, and also feeling happy to be in this session with the youths. So let me start with sharing my screen. And please let me know if you can see my screen, the presentation
Correct.
in full.
Yeah, please go ahead, sir.
Okay. Thank you again. So this is a really interesting talk, and I think like this is the first time I'm giving this talk. So this work is started since I think 20 like end of 2021 or something. I got a call from RCC Pune and from Dr. OP Srijit, who is the head of the seasonal prediction. And that's the time like IMD is thinking about like to have some experimental model for seasonal prediction of tropical cyclone. So, and it was a really, really good collaboration with Dr. Srijit and Dr. Sabir Ali from RCC Pune and IMD Pune. And we developed something, and that's what I'm going to present today. And it will be some time it will be in operation in next year. So let's see how it works. So before I start, there is some terms we should know, like talk about tropical cyclone, but there's a different definition of cyclone, depression, deep depression, severe cyclone based on the uh, like the wind, maximum sustainable wind. So today we're mostly talking about two different criteria of the disturbance. One is cyclone disturbance, so anything more than 70 knots of maximum sustainable winds, and cyclonic storm or named storm, which is anything greater than 34 knots. So try to predict this thing in seasonal scale. So before I start, just a little bit of idea, whoever not such idea about tropical cyclone of North Indian Ocean. So we have a monthly climatology, and I just plot here cyclonic storm and cyclone disturbance. One is in blue, one is in red. And you can see there's active season mostly in the pre-monsoon and post-monsoon. But today we're really interested on the post-monsoon, and there's a reason behind that. The reason is the post-monsoon season is very interesting. So post-monsoon season is also included with the northeast monsoon, like October to December, the southern part of India, including Sri Lanka, got the rainfall. So the monsoon with the cyclone in this season make it very, very vulnerable for the society. So that's what we're mostly interested on that part. And also, if we plot the whole 100 years or more than that cyclone frequency, we found the Bay of Bengal is more active than the Arabian Sea. So that's what we are mostly interested today's talk on October to December Bay of Bengal seasonal prediction of tropical cyclone. But why we need the seasonal prediction? Because we know like Indian Meteorological Department or RCC Pune is like extremely good in predicting cyclone in short range to medium range. But why we need the seasonal prediction? So obviously, if we know the number of cyclone or deep depression beforehand, we can plan uh, on the disaster management aspect or the insurance aspect or so many different things. So it's not like we can predict like when will be the cyclone or where will be the cyclone, but we can know like whether this upcoming season is like above normal cyclone or the below normal cyclone. Based on that, the contingency plan can be planned in that way. So that's what we really need, that kind of seasonal prediction. Except India, like all over the world, the system is already there. Like, from the NOAA perspective, we have the seasonal hurricane season. And also from Colorado State University, the Bureau Meteorological of Australia, they have this thing. So the question is like, if every part of the world has the seasonal prediction, why don't IMD has the prediction system? And it's like too tough as a rocket science that IMD cannot make it in 100 years. It's not like that. The biggest problem is most of the part of the world got a lot of cyclone or hurricane. If you look at this NOAA outlook in this summer, you can see that they are predicting like at least 14 to 21 named storm or 6 to 10 hurricanes. But we did not get that much of prediction, that much of cyclone disturbance in this part. We may got like 3 or 2, max 4. So when you have a less number of sample size, it's always tough to predict something in terms of statistical analysis. So it's not like it's very tough to predict, but it might be a very either overconfident or underconfident prediction because we don't have much sample size. So that's one of the limitation, that we don't have this seasonal prediction up to yet. And there is others. So I'll come back one by one. So what is the previous attempts do? Like we are just start this prediction or it's there already. So there's a lot of study, but one of the study I really want to mention, which is study by Dr. Patnaik, who is also in IMD Delhi, and the current DG of IMD, which is Dr. Mahapatra. So since I think in 2016, 2016 they published a paper. They tried to find a relationship between number of cyclone storm and cyclone disturbance based on some large scale atmospheric and oceanic variable, but most of them is actually precursor. That means the the SST in June to August, or the wind or the sea level pressure is July to August, they use some kind of precursor to predict the forecasted OND. So what happened, the biggest limitation is, first of all, the relationship between these environmental parameters with the cyclone disturbance and storm is not actually maintaining. That means due to the climate change, the non-stationarity of the relationship is going to end. So the correlation, if we calculate the correlation again, so this correlation based on 71 to 2010, 20, but if you just redo the same thing from 1980 to 2020, the correlation is actually very less. Second, like, yes, there is a relationship of precursor, but what we found, the concurrent or the simultaneous predictors also have a huge importance. But what happened in this study, they're mostly using the reanalysis data, which is the kind of proxy of observation data. So if you know there is a concurrent relationship, let's say the wind in OND has more correlation of OND disturbance, you cannot predict in real time, because by the time you get the reanalysis data, the season is over. So that one of the limitation, that they only use the precursor. So in our study, with a lot of correlation and other thing, we found a set of predictors, and some of them is concurrent and some of them is precursor. We found that wind and the easterly jet wind over African coast and Indian Ocean coast from July to August has a correlation which is kind of significant with the cyclone disturbance and storm. But that is like we can use the reanalysis data for that. But we also find there's at least three concurrent prediction. For example, SST at Nino, SST at Indian Ocean Dipole, and the oceanic heat content. Those predictors has a concurrent relationship. That means that the OND of OHC, or oceanic heat current, has a highest correlation with OND of number of cyclone. So we found that there's like some concurrent and precursor, and also try to find whether this relationship is kind of stable. So we calculated a 21-year running correlation mean, and we found this relationship in recent past, which is 82 to 2020, is actually have a strong predictor. So it's not like drop down in any year. So we found like, okay, so those 5 can be a excellent predictors. But again, the challenge is, how can we get this concurrent prediction? So for that, what we found, for the concurrent predictors, we take the dynamical prediction of the model. So for example, like IMD use the CFS, which is climate forecast system, for seasonal prediction. So we use this CFS forecast of those oceanic heat content on Nino 3.4 SST or IOD SST, and use them as a concurrent, so that we don't have the reanalysis, but we have the prediction from the dynamical model. So that's what we name it hybrid. So some part is still reanalysis data from July to August using N7 car or ERA 5, but some part we use the dynamical model predictions. And once we have all the prediction, then we simply do statistical modeling, which called principal component regression, and I will come back on that and why we choose this principal component regression. So coming back to a little bit of, because we are suggesting that we should use a dynamical model prediction for those concurrent, but the first question comes that how well those parameters are predicted by the CFS2. For example, Nino 4 Indian Ocean Dipole or OHC over Bay of Bengal. So we kind of plot again 20 years of 25 years of correlation, and we found like the correlation is really significant, although there is some systematic error, and that easily to correct, because if you look at the Indian Ocean SST, there is a like 2-degree difference, and you can easily correct it with simple mean bias correction. So for us, it's more on the correlation than the mean bias. So we thought like, okay, so it kind of like, if we have the original thing, it might be the correlation is 1, but if you don't have the original, but you have the dynamical prediction, the correlation is 0.9. So it also useful for making this prediction. Now we want to show another limitation. The limitation is like, we talk about 5 predictors, and it has like all the 5 predictors has a correlation with the predictant, which is number of frequency of cyclone disturbance or cyclone storm. But what if they have highly intercorrelation, and which we found that means like each predictors which are going to use for any kind of statistical model, if they have a highly intercorrelation, it will impact the prediction system. And in statistical language, we call it multi-coordinate problem. So whenever there's a multi-coordinate problem, or if you think about there's a two or more variables highly correlated, they essentially convey the same information. And mathematically, calculating the least square using those kind of highly correlated is impossible. So we cannot use simple linear correlation like other study to have those all the predictors. So that's what we come up with the idea called principal component regression. And what is that? In a simple way, if you think, like instead of thinking a linear regression between two predictors, we just add one more step. We first calculate the principal component of the predictors and then make the predicted, then make the model to the predicted. So what is principal component analysis? Principal component analysis, basically it's actually a dimensional reduction system, or basically from the real field, you change a field which is based on eigenvalue eigenvector. But in a simple sense, principal component is the linear combination of the data, and each of the principal component is uncorrelated. That means the angle between two principal components is 90 degree. If you look this little scatter plot, this is like the orange dots are the real data. So you can calculate the combination of principal component in two different direction, and these two different direction is like orthogonal to each other and explaining the most of the information from the data. So instead of using the data, we are using a combination of the data which are actually explaining the most of the variability as well as they are uncorrelated to each other. So that's what we do this principal component regression instead of simple linear regression for this model. And after that, we kind of test our model. So we have a data from 1982 but 2020, but we just use this out cross validation from 1982 to 2016 and try to find like what is the scale of our prediction. And most of the cases, the prediction is not so bad. It's kind of moderate. Like the mean of the cyclone distribution in observation is 3, and we also predict the same 3. Also the standard deviation, if you look, it's kind of 1.51. So it's also good, and also the correlation and index of agreement, the Klingupta analysis, like so many different way we try to find our model, whether it's correlation or mean bias, and we found the RMSE correlation is kind of moderate, so we can have some confidence on that. But we kind of keep the other 4-5 years to try to make it like a mimic, like kind of try to make a real-time prediction. So what happened here? Let's say we make this prediction model based on 1982-2016. Suppose we go back and thought about what happened if we make this real-time prediction in last 5 years, how the prediction skill occurs. Because in when you develop a model, we use kind of 3 cross out or 5 cross out or 1 cross out cross validation. But when you make the prediction, you're using all the past data. So that way kind of try to make this 5 years prediction, and you found each year the prediction is very close to the observation, except 2017, or like you can see like just one difference in cyclone disturbance, and 2020 just one difference. But most of the cases, except 2018 in a cyclone storm where you kind of underconfident, like we just predict 1, it's come 3, but most of the cases kind of really work. So we kind of test this thing as a real-time prediction system so that we have more confidence than just cross validation. And then we actually predict this year, and we presented this forecast in the month of September in a South Asian Climate Outlook Forum, where BMD, IMD, and all the Met Department on this part of the world, which is Indian subcontinent, we kind of meet and make it the consensus forecast for the Northeast monsoon. We also talking about this cyclone forecast, and we predicted 4 cyclone disturbance, and we predicted 2 cyclone storm. So I just took this plot from IMD Pune, and up to now we found there's already 3 cyclone disturbance happen, and there's 2 named cyclone storm, which is Sitrang, and the last week the Mandos happen. And we just talk to the morning with Srijit, and he said like there might be one more is actually brewing. So the whole thing, which actually give us a lot of confidence, because in real time for this year we kind of almost 100% correct with our forecast. And based on that, maybe we can do more experimental years in coming years, and then it will be like in some point real-time prediction system at IMD and RCC Pune. On that note, I want to conclude. So we found this proposed hybrid model, which is concurrent and precursor predictors using dynamical model and reanalysis and using principal component regression make more sense in real-time prediction. In future, we're thinking about instead of just having one dynamical model from CFS, we can actually use the multi-model system from North American multimodal system or Copernicus multimodal system to make this concurrent prediction more useful. And also thinking about instead of just a principal component regression, we can also use some kind of machine learning method. But I kind of a little bit of reluctant to use machine learning here because as I started with, we have a very like less sample size, like 2 or 3 every year. Machine learning is very fascinating, but we need to think about it actually data hunger process. We need a lot of data. So kind of thinking about which could be a excellent interpretable machine learning model for this case. And just for reference, we published this paper earlier this year in International Journal of Climatology, sorry. And in that way, I think I'm in a time.
Thank you.
Thank you very much.
Thank you so much. Thank you so much, Dr. Acharya. And now we will have the questions at the end of the session. We will move to next presentation by Shabizta Yildiz. The title is Assessing Future Drought Characteristics in Bangladesh using bias-corrected CMIP6 data. Shabizta, please. Please go.
Am I audible, sir?
Yeah, very much. We'll share 15 minutes. Just 3 minutes, we are running behind. Maybe, we will make up. Please go ahead. Is it working?
Thank you, sir.
Yeah.
So very good morning and assalamu alaikum, everyone. This is Rabi Sayandis from Department of Meteorology.
Your PPT is not seen.
Yes, sir.
Your PPT is not seen. PPT is not seen.
Oh, I see.
Shavish, so we can only see your screen, but not your presentation.
Sir, is it now visible?
Yeah, now visible. Just make it in full square. Yeah.
So today I'm going to present my thesis topic, which is on assessing future drought characteristic in Bangladesh using bias-corrected CMIP6 data. Let's go. So before going to start my discussion on this, I first want to justify that why I have chosen this topic, and let's start off with the definition that I have used here for drought in my study. It is basically a period of it is basically a dry period with deficit in rainfall compared to long-term average, with high temperature, low humidity, high evapotranspiration, and wind speed. And obviously, this definition may vary according to geographical extent and rainfall intensity from country to country and region to region. As per Bangladesh, we consider a period as drought if the rainfall is like 20 to 25% lesser comparing to its average. And now if we go through some literature review, then I have gone through, so that's where I have found that pre-monsoon droughts are very prominent in our country, and between 1961 to 2010, the Northwest region was very prone to drought. And in another study, they have calculated the drought frequency between 1979 to 2080, almost 40 years, and they have found that on an average, 10% drought is increasing along the northwest region of Bangladesh. And its impact is not less on the aggregate production and agriculture of our country. So this is a very important topic in the context of current climate change and climate extreme. So that is the reason I have chosen this topic for my thesis. And here goes the objectives under which my thesis has been carried out. The first one is to analyze the temperature and rainfall climatology under SSP scenarios, and then I have calculated a drought index on 3-month scale, and then I went for the spatiotemporal distribution of drought characteristic over Bangladesh under these scenarios. So if we see Bangladesh from a meteorological perspective, then we have 4 main seasons. The hot pre-monsoon season, basically it is between March to May. The humid monsoon season, that is between June to September, and for post-monsoon, it is between October to November, and the winter is between December to February. But the rainfall varies from the northeast from northwest in a great gradient. It is like 4,000 millimeter in the northeast, while it is 1,500 millimeter in the northwest. Sorry. This is the more or less the workflow. I started off with literature review, then go for the formulation of objectives, which led me to the collection of data. So what I have used in this study is the Copernicus data for my reference data set, and downloaded the data from CMF6. You are combining them. I go for bias correction and downscaling using simple quantile mapping method, which led me to the calculation of drought index, which is the potential evapotranspiration calculation using Penman-Monteith equation. And then I have went for the my drought index calculation, and finally calculated the characteristic of the droughts using theory of France developed by Eusebius in 1967. So here goes the outputs. I have selected 5 models for my study after literature review, which actually best represent the rainfall climatology of Bangladesh. And then I have seen that how was the rainfall trend in the historical period and how will it be in the future period. And from that, what I have seen that there is a significant increase in the rainfall trend and also in the temperature at 95% confidence. So I have found that under SSP 2.45, the rainfall may rise by 3 millimeter per year between 2020 to 2100, and in 8.5 scenario, the amount is like 4.96 or 5 millimeter per year between this time interval. The temperature is also showing a rising trend. This is annual average temperature, but the rise is a little higher in like SSP 5.85 scenario comparing to SSP 2.45. So these are the spatial changes in rainfall. Let us take a look at the maps. The first one is for SSP to 4.5 scenario for the interval 2020 to 59. In this period, I have seen that the rainfall may decrease by about 5% in the northeast Bangladesh, which is actually high rainfall area for Bangladesh because of its orographic barrier. But in future, there is a probability that rainfall is going to decrease by as much as 5% in that interval in this scenario. And for the rest of the country, the rainfall will rise. In SSP 8.5, the rainfall will rise much higher throughout the country for both time interval from 2020 to 2059 and also 2060 to 2099. Here goes the changes in temperature. The first row is showing the changes in maximum temperature, and the lower row is showing the.
Shvesta, you have 5 more minutes.
Yes, sir, I'm about to finish.
Yeah.
So these are the spatial changes in temperature. The minimum temperature is rising much more higher comparing to the maximum temperature. And here goes the changes in frequency, that how drought will change. And let us take a look at the graph, look at the maps. So from here, I have found that the frequency of drought will reduce for Bangladesh between 2020 to 2059, more or less throughout the country under both scenario. But for the later period, which is between 2060 to 2099, the frequency will be rise higher comparing to the base period, 1985 to 2014. And the rise will be much higher in the western boundary along the country comparing to the eastern region. I think I should skip this one. Let's focus on this. The long duration drought. This is a long duration drought frequency, basically, where the duration is over 6 months. And I have found that in historical period between 1985 to 2014, these kind of droughts are concentrated in the northwest part of Bangladesh. But in future, these will shift toward the south and center of the country. So there is a probable change in the spatial pattern for this kind of droughts. And again, towards the end of the century, the frequency will rise again higher in the northern region. So this is the changes in severity. So the changes in severity tells us that though the frequency is rising higher in the northeastern part, but the severity is decreasing in that region. But the severity is increasing in the northwest part, the frequency is lower in that part. So there is a kind of trade-off between the spatial pattern of severity and frequency. And in the next half of the century, which is between 2060 to 2099, the drought frequency will rise much higher in the northwest part and the central portion of the country, which is between like 4% to 8% increase in severity. So to conclude this, I want to say that the severity and frequency, that I have found a like inverse relationship between this. And for long duration drought frequency, I have found that there is a shift in spatial pattern from the northwest to the central region. So now, do you have any questions? Thank you.
Thank you so much, Shrista. You are back to you for questions at the end of the session. We can now move to next presentation by Muhammad Afzal Hussain on collection, quality, control, and curation of ground data for continued development of satellite-based crop area monitoring system for Bangladesh. Muhammad Afzal, please. Yeah, please. Please make it full screen.
Yes, I'm making it. I hope I'm audible.
Please, you are not audible. Can be little more loud.
Yes, sir. I can. I think now it's fine.
No, still. You are audible, but not clearly. Yeah, this is fine. This is fine. Only audio is the use. Only this you display full mode.
Sir, I think.
Yeah, now
I'm
it is
fine.
okay. Now it is okay.
Thank you, sir.
Just yeah. Yeah.
Good morning.
Please go ahead.
Good morning, everyone. I'm Muhammad Afzal Hussain. I'm here to present my thesis overview. This is the topic I'm working on.
You can be still more loud actually, or be close to the mic speaker.
Yes, sir.
Yeah, now this is, yeah, please.
This is the topic actually I'm working on. Collection, quality control, and curation of ground data for continued development of the satellite-based crop monitoring system for Bangladesh. Actually, as we all know, Bangladesh is an agricultural country. Most of the people here are related to agriculture in directly or indirect way. So it is very important to have a proper crop management system. For that purpose, I have chosen this topic so that I can help to this crop management system of our country. The main objective of my study is to predict and monitor the crop so that the decision maker can make decision about crop production and proper crop management. And the future vision of the study will engage more people to the crop management system, and people can have their data or any information about crop will about to know within a click of his or her computer. The methodology I have used here, I can divide it into two parts. First part is the field visit, and second part is the data analysis. For field visit, I have selected several study area and collected data from those area, which is also used for the ground truthing. And for the data analysis, I have selected Sentinel-2 images, and as for analyzing tool, I have used Google Earth Engine and ArcGIS for this purpose. I'm coming to the result directly. I have divided my result part into three segments. First one is crop area monitoring. The second one is crop type identification, and the third type is crop phenology monitoring. As I have dealt with the Rabi season, which is basically the winter season of our country, also known as the Boro season for rice crop cultivation. So it starts in October and ends in May. So my result here, I show my result in this graph. We can see that the area of no agriculture is very larger in the May and very small in the December, and the area of cultivation is larger in the December, and the area of no agriculture is very large in May, because the season starts in October and December is the sowing season for many crops in winter season, and May is the harvesting season. And I also validate this convention through my study. Then I come to crop phenology, which is the physical development stage during the season of a plant. Here I have calculated NDVI values from satellite images, and with the help of ground data, I have managed to validate that the phenology distribution, the NDVI distribution throughout the phenology is like that. The phenology is lower in the planting season and lower in the harvesting season. In the middle part of the season, the NDVI value is higher. If we see this graph, we can, it is evident that NDVI decreases with time as the greenness of crop degrades. And the NDVI value changes with variety and time. We also concluded that NDVI value is higher in the reproductive stage. This is the phenology I have identified from the analysis I have done. In the month of December, the crop are in vegetative state. In the month of March, they are in mainly booting and flowering stage, and in the month of May, they are come to harvesting stage. And the last part of my result, which is basically the crop type identification. Actually, I'm currently working on it on Google Earth to set an algorithm that can define the crop type, but I haven't finished it yet, so I couldn't show you the results. But hopefully, I will make a result very soon, and let's see, I can show you. Thank you for the time.
Thank you. Thank you for keeping the time. You have finished much before I expected. You are still 10 minutes left. I mean, but maybe we can move to next. If honorable co-chair is there, then you may also express or you can take over. But next we can go to next presentation. If this is done, Rahan Mohammed Chaudhary.
Yes, sir.
Yeah. So you are ready?
Yes, sir.
Yeah. Characteristics of severe local convective storm observed by Doppler weather radar and their simulations using cloud resolving scale model over Bangladesh. You have sufficient time. Yeah, please go ahead.
Sir, thank you, sir. So, am I audible? Respected chairperson and co-chair and everyone else present, assalamu alaikum. Very good morning. Today I'm here to present my ongoing research on the topic characteristics of severe local convective storms observed by Doppler weather radar and their simulations using cloud resolving scale model over Bangladesh, which is being supervised by Dr. Fatima Akhtar, Assistant Professor of Department of Meteorology, and Professor Dr. Shamsher Das, who is also visiting professor of Department of Meteorology. And I'm scholar leader Raihan Mahmood Chaudhary, professional student, master's 4th batch, came from Malaysia Air Force as a professional student for the first time. So can you see the screen? Sorry.
Yeah, please go ahead.
Your mic is on.
Please.
Yes, sir. The sequence is shown in the screen. And today I will discuss the objective metrology and then results and discussions and then expected outcome. And then I will try to conclude it within next 12 to 30 minutes. So for this research is actually about finding the threshold reflectivity for different kind of harvester and their intensity, which occurs during the month of March, April, and May, and which peaks during the month of April. And for understanding this mechanism of severe local convective storms like nor'wester, the simulating with the help of high resolution non-hydrostatic mesoscale models can be used as a tool for forecasting. For choosing the topic, the purpose of my study is to diagnose the physical and dynamical characteristics of nor'westers over Bangladesh using radar data, which may lead to formulate an ensemble system for early prediction. It can be achieved by simulating these events with the help of high-resolution non-hydrostatic mesoscale models like global cloud resolving models, GCRMs, which are a new category of atmospheric global models designed to solve the different flavors of non-hydrostatic equations, which actually allow the forecaster to simulate deep convection, thereby avoid the cumulus parameterization. The objective of my study is to find the threshold reflectivity to be used as precursor for the presence of different kind of severity in the weather system, and to forecast about the weather system, whether it is light, moderate, or intense, and to predict the observed weather features found in radar by the NWP model prior to 24 hours before the occurrence. And finally, to complete the scale scores and compare with the previous one. So the workflow is to make the ensemble members of the model, which we chose 10 ensemble members for 5 cases. In total, there were 50 model. And then after finding the outcome, we calculated the scale scores. And then in this presentation, we will discuss about how we can formulate an ensemble focus system. Methodology. For this research, we took the Doppler weather radar of Bangladesh Air Force as an observational data. We assessed the data of the Doppler weather radar with the model forecast data. And then we simulated with the numerical weather prediction model. ARW version 4.1 was used for this research. And finally, assessment of the dynamical features by comparing both radar and model derived products with the ground station observation and also synoptic data. Before going to discuss the result and discussions, here the specification of the Doppler weather radar is given in this screen. Its maximum range is 480 km and effective range is 250 km. These are the 5 cases I chose for the research. And this is the details of the model and domain, version WRF 4.1 and
go slow. I mean, these cases, you may just highlight some cases or something. Yeah, please. You have time, sufficient time, so don't rush. Please.
Sir. Okay, sir. So these are the cases I chose, 5 cases total, with from 2019 to 2021. Most of the cases I took on the basis of the wind speed more than 25 knots. Model WRF 4.1 was used for this research, and we used the data GFS 0.25 degree global, that is 28 kilometer data. And domain area is shown in the screen at the right side. And then resolution, we took 2 kilometer for single domain. And the forecast run hour was 30 to 36 hours. So for some cases it was 30, and for some cases it was 36 hours. With an aim to predict the weather 24 hours before. So we took the initial condition at least 24 hours before the occurrence. These are the 10 ensemble members, the 10 scheme parameterization, those we could run successfully. Here is a sample of the comparison between radar product and the NWP product, just for your better understanding. So finally, the result and discussion for computing the an ensemble forecast, we tried to have bias, RMSE, and correlation values for skill scoring. For that, we took 3 hourly values of actual versus forecast reflectivity. At first, we considered the actual versus forecast reflectivity for 20 different points of BMD station, which were within the 300 kilometer of the range of the radar. And secondly, we tried to make area average for reflectivity for every time step with a moving box according to the movement of the weather system. So first, I will show you the result by the 3 hourly for actual versus forecast reflectivity. These were the 20 stations, 20 pinpoint location we choose, which are actually the BMD stations. So they give or provide the regular 1 hour interval meter data. So all these stations are within the 300 kilometer range of the radar. This is the first case, the result of bias and RMSE and correlation you can see in the screen. So as natural, the bias and RMSE increases with the time step, and correlation coefficient values are quite irrelevant because we took some pinpoint stations or pinpoint 20 places all over the Bangladesh. So these all the cases, 6 April 2019, then 23rd April 2020, and 4 April 2021. In all the cases, we found that the bias and RMSE increases with the time, but the correlation coefficient remains below 10%. So it was quite irrelevant. So to avoid that, we tried to find the correlation coefficient with an area average value, 3 hourly area average value of forecast actual versus forecast reflectivity. So now the ensemble mean by area average. So this is the way how we took the area average, 3 hourly, 6 hourly, 9 hourly, in that way 30 hour, and for some cases 36 hours. In this way, sir, we took all the averages for different places, and we found this ensemble mean of correlation, which is quite relevant and more than 30% for all the models that we ran for all the ensemble members. So these are the averages of 5 cases and all time steps. And RMSE and bias value shows an average value here, but it is in an increase trend. So the final findings, we found that the average value of all 5 cases every after 3 hours shows a good correlation for all model except 1, 2. But it indicates that whatever the scheme we choose for WRF model for forecast, bias and RMSE for reflectivity will increase with every time step naturally, but correlation value for reflectivity indicates that the model can predict the intensity of the weather most of the time. After having a count for every time step for reflectivity more than 45 dvz, we found that for more than 70% cases, models predict correctly about the severe local convective strokes or the nor'westers. So that was the findings of my study so far, as it is already it is an ongoing research. So finally, sir, we will formulate an ensemble focus to conclude the research study. As we try to focus the nor'westers or severe local convective storms prior to 24 hours of the occurrence.
Yeah.
We took all the initial conditions around 30 hour or 24 hour or 36 hour. The models showed that more than 7% cases it can predict the intense weather systems which are mainly 45 degrees or more. Thank you, sir.
Thank you. Thank you so much. Nice. We'll go to now next presentation. We still have time actually, but if it is done, then again we will go to next presentation by Mohammed Saifur Rahman. Saifur Rahman, yeah, please go ahead. Change in crop water requirement and yield of boro rice in Mymensingh under future climate conditions. Please go ahead.
Thank you.
Yeah.
And
be slow.
okay.
Presentation. Yeah. we have time actually. Yeah. Put
Okay.
it in full
Yes,
screen
yes.
mode.
Trying to figure out. Okay.
Yeah, good. Go ahead, please.
Good morning, everyone. And thanks for giving me such an opportunity to present this presentation. Myself, Mohammed Saifur Rahman. I am a student of MSc student of Department of Meteorology, University of Dhaka. And my, sorry, slide is not changing. Okay.
Yeah. Please go ahead. Please
Okay.
go ahead.
My thesis title, my thesis title is Change in Crop Water Requirement and Yield of Boro Rice in Mymensingh under Future Climatic Condition. And in today's presentation, I will go through this area. First of all, I will give some direction and the objectives and the novelty methodology, models, description, bias correction data, SIMF6 models validation data, and then some results and key findings, and then conclusion. The contribution of agriculture sector in Bangladesh is nearly 11.5% in GDP growth, which is a huge percentage. And Bangladesh has achieved recently the third position in global rice production. And the total rice production in 2020-21 is 376.08 lakh metric tons, which is a huge number for Bangladesh. But the expected production was much more than that, which was the 394.81 lakh metric tons. And Bangladesh has imported rice worth of $851 million last year. And the loss of this rice, the huge amount of rice, is due to climate calamities, which is according to Global Climate Risk Index 2021, Bangladesh is listed 7th most affected from 2000 to 2019 due to climate change. And Bangladesh is said to be poster child because of facing climate calamities, in spite of nearly no contribution to global climate change, which indicates that Bangladesh is facing climate calamities in a worst possible way, because there's this climate change or climate calamities is causing the harm. And so a comprehensive analysis of crop water requirement of rice, especially irrigated rice, that is boro rice, Bangladesh, in case of future climatic scenario, including irrigated rice yield, is necessary to understand the impacts of future climatic conditions on irrigated rice cultivation for future planning and management. The objective of this study is broadly in broad perspective is to evaluate the change in the future climatic condition in the north central hydrological region of Bangladesh, which is Mymensingh division, for Bangladesh, and under different shared socio-economic pathways, that is a climatic scenario. In this study, SSP 245 and SSP 585 has been chosen, which are most recent scenario from coupled model intercomparison project phase 6, which is CMF 6 formulated by IPCC. And to assess the crop water requirement of Bodo rice, specifically said to BD Dhan 28, under future climatic condition over the study area. And to estimate the yield of Bodo rice in the relation with under future climatic condition. So these are the objectives. And novelty and the contribution to the research gaps. The novel aspects of this research are, in broad perspective, only few studies like Amaruzjaman et al. 2021 in Bangladesh ranked CMF 6 models according to its performance for different weather variables like precipitation, temperature, humidity, etc. This study shows a ranking of CMF 6 models based on their performance on future projection for different weather variables. And some publications like N.D. Belal Hossain et al. 2021 showed how Bodo rice production decreases with the increase of temperature for 1 degree, 2 degree, or 3 degree, and 4 degree. But in this study, we tried to show how Bodo rice production decrease with the projected future climatic scenario with a specific number that temperature increase or the precipitation increase or decreases. And MAH Jahan et al. 2018 showed a reduction in wild yield in kg per day per hectare. Kg per day per hectare unit. In this study, this methodology is followed for the Bodo rice yield production. And this is the methodology in a shortcut flowchart. And I go through, we go through literature review first, and then problem is identified, then the model was adopted. In this model adaptation, we downloaded CMF 6 models from the website and collected the BMD, Mymensingh BMD station data, which is Bangladesh Meteorological Department data for as observed data. Then statistical downscaling and the bias was corrected with the simple quantile mapping or SQM method. And then the validation was done. And then the validated weather file is included in crop modeling, which is in this case, DSET 4.7 is used for crop modeling. And then simulation was done, then the data processing analysis, then findings of the study, report presentation, and submission. For more details or for model and data description here, the CMF 6 models, 5 CMF 6 models were chosen. They are XSCM2, XSESM15, CNRM CM61, ECR3, and MRI ESM20. The study area is already said that Mymensingh division. Observed data is 1985 to 2020, which was collected from Bangladesh Meteorological Department, Mymensingh Station. And 2 SSPs are chosen here, SSP 245 and SSP 585. And historical period of both CMF 6 and observed data is defined as 1985 to 2014. And the projected period is from 2015 to 2100. And the validation period is 2015 to 2022. And the downscaling and the bias correction technique is SQM, which is a simple quantile mapping, which is a statistical downscaling technique. Variables were taken maximum and minimum temperature, precipitation, humidity, wind speed, and solar radiation. And the crop was chosen is irrigated rice, which is Bodo rice, more specifically BD Dhan 28, and the season is Bodo season. Here is some data which shows that the weather variables from the CMF 6 models, from the CMF 6 model before bias correction and after bias correction seen. Here the precipitation is shown in the left side of the graph of the slide. The before bias correction was shown here, that 5 models and the observed data is like scattered way. But after bias correction, in this scatteredness is much more reduced form. And this bias correction is done with the SQM method. And CMF6 model validation, we have already told that the same 5 CMF6 models were chosen. Among them, for these 5 variables, precipitation, maximum temperature, minimum temperature, relative humidity, wind speed, and radiation, these 5 models performs in that way. And this percentage showed the correlation of observed data and the model data. But in the long run, or the ensemble data of these 5 models shows the best possible outcome for the projected future projected value. So in this study, we didn't take the single model output, rather than we took the ensemble one, and the ensemble one ensemble one projection in a box plot is here. For precipitation, we can see that the annual precipitation, total precipitation, is in increasing trend. And if we see the monsoon and pre-monsoon season, and then for the far future, total precipitation is in higher increasing trend. And for the maximum temperature, it is also in an increasing trend, about 3.5 degrees Celsius is increasing in the far future. And the minimum temperature, it is also in the increasing trend, and it's more like 4 to 4.5 degrees Celsius increase in the far future. Next, with the Bodo season mean temperature in future, we know that the Bodo season is in Bangladesh is from the November to April. So in this time period, the mean temperature for SSP 245 temperature is increased about 2.5 degrees, and for SSP 585 the temperature is increased about 6 degrees. Which is a huge amount. And these graph shows in the left side to SSP 245, and the right side SSP 585. The increasing trend is shown here for mean temperature in Bodo season. And here some decent output for crop water requirement. And then as we can see, the temperature is rising. So the crop water requirement for Bodo rice is decreasing day by day. Here is some graph shown here, that in the left side, evapotranspiration is decreasing day by day. And then in the right side, we can see that from 2022 to 2047, in this time period, the normal crop water requirement is decreased. And in this manner, for every 25 years interval, it is the decreasing trend is much severe. And decent output for grain yield of Bodo rice. Here we are seeing that the yield or the Bodo rice production is also decreasing because of the temperature rising. Here in the left side, SSP 245, and the right side in the SSP 585 is shown here. And then key findings of this study. First, climate models. We have already said that ensemble CMF6 model shows the best result for future projection. And crop water requirement. Crop water requirement shows decreasing trend. Sorry. Crop water requirement shows decreasing trend in future climatic scenario. For SSP 245 scenario, crop water requirement reduced about 73.26 millimeter in next 79 years. And for SSP 585 scenario, it reduced about 122.55 millimeter in next 79 years. And the grain yield shows decreasing trend in future climatic scenario. Also for SSP 245, it's reduced about 527.48 kg per hectare for 2.5 degrees Celsius temperature increase. And for SSP 585 scenario, yield reduced about 2,556.323 kg per hectare for about 6 degrees Celsius temperature increase. And for SSP 2.5, if we convert this reduction into percentage, for SSP 245, it's reduced about 9%, and SSP 585, it's reduced about 43.75%, which is a huge number. And if we calculated this in a kg per day per hectare unit, for SSP 245, yield reduced about 27.71 kg per day per hectare, and for SSP 585, about 66.63 kg per day per hectare. And so in the conclusion, we can say that elevated air temperature affected lifespan and grain yield of irrigated crop, but it reduced the seasonal crop water requirement that results in less irrigation demand. Elevated temperature shortened the crop growth duration and reduced the crop water requirement. In response, the reduced crop water requirement will decrease the irrigation demand and consequently the number of irrigation days. The combined effect of less irrigation demand and irrigation days will save huge amount of irrigation water currently required for Boro dry rice cultivation, in Mymensingh. However, the reduction in crop growing period due to temperature rise will cause yield reduction of current rice cultivator. It would be a near future challenge for crop developers to introduce a new type of cultivar which can tolerate the effect of elevated temperature with no significant yield loss. Thank you all for hearing this speech, and if anyone have any questions.
Thank you. Thank you so much. We'll have the question at the end. Actually, I never estimated that we will be running well in time. Otherwise, we would have taken the question simultaneously.
Okay.
But since we started from the beginning, we will do add this question at the end. Thank you so much. Thank you so much, Mr. Saifur Rahman. Now, next we will go to Lisa Parvin. Lisa Parvin, are you there? Lisa Parvin. Next presentation by Lisa Parvin, are you there? Saurav, is Lisa Parvin there?
We couldn't see her. I just communicated.
Yeah.
I think we should move to next.
Next, okay. So, so next we will go to Munmun Akhtar, climatology of western disturbances and associated precipitation over Bangladesh and adjacent areas. Munmun Akhtar,
Hello,
yeah.
Okay. Thank you, sir.
Yeah, your voice is very low.
I'm interrupting for a second.
Yeah, please.
Actually, Lisa Parvin got sick, so she will not be able to, give her presentation.
Okay.
So just inform me. Thank you.
Okay.
Assalamu alaikum. Good morning.
Yeah.
The title of my topic is Climatology of Western Disturbance and Associated Precipitation over Bangladesh and Adjacent Areas. I am Munmun Akhtar. Now I am going to present my work. Firstly, I would like to share a short definition of Western disturbance. Western disturbance are mid-tropospheric cyclonic circulations that typically originate over the Western Eurasia before propagating downstream across the subtropical westerly jet stream, northern India, and it extended to Bangladesh, where they can be responsible for catastrophic rainfall. At the right side of the picture, is shown the cyclonic circulation migrate eastward and embedded to the northern India, and it extended to Bangladesh. Some significant features of western disturbance: the main jet stream over the Indian subcontinent lies near latitude 27° north in winter, and height is about to 200 millibar when the wind speed remains 100 knots. Frontal cyclonic system as upper air troughs has a life cycle that can turn into many forms. Winds precede the trough, increase intensity, and cause the divergence, increasing the vorticity due to the movement of air mass from higher to lower. Here is some newspaper cutting pictures which shows the winter rain in Dhaka, Mymensingh, Tangai, and some other districts of Bangladesh. It was published 23rd January and 4 February of 2022, and the rain was caused for western disturbance. The outline of my presentation are: firstly, climatological behavior of western disturbance in Bangladesh from 1979 to 2020, and second one, investigation the dynamic features of the western disturbance during winter season in Bangladesh. And lastly, I have chosen one case from very recent year 2020 is presented as an example. The datasets I have used for my study are listed here. For analyzing climatological behavior of WDS, we have used ERA5 datasets. And then for model simulation, we have used NSEP and FNL data, and we have validated model outputs against ERA5 and IMD reanalysis datasets. I have also used INSEP 3D datasets. Here is my model domain. You can see for WRF model simulation, the parent domain covers the Indian subcontinent with a gate resolution of 27 km, and the nested fine domain covers the Bangladesh and its surrounding areas with the resolution of 9 km. Now I am showing the rainfall anomaly during the winter months of December, January, and February from 1980 to 2020 using ERA5 datasets. For calculating anomalies, at first, I took the average rainfall over the period of 1982 to 2020. Then I have subtracted daily rainfall from the average one. Here I am presenting those results of anomalies with a different figure showing 10 years each. I have counted the days that receive rainfall greater than 3 rainfall threshold of 5, 10, and 15 millimeter. From here, you will get the days that receive rainfall over the period during winter months. At the last of the first table, it is colored with red color, and you can see that in the January 2020, 3 and 5 January, Bangladesh received 8 and 7 millimeter rain respectively. From this one, I have simulated a case, and I will show it at the last part of my presentation. Now you will see the seasonal and monthly climatology of WDS. To understand seasonal and monthly climatological behavior, some meteorological parameters related to WDS, such as precipitation, relative vorticity, geopotential height, and wind speed and direction over the period of 1970 to 2020. In the results and discussion part, I have shown the average precipitation of winter months from 1979 to 2020. And here, the rectangular box, into the rectangular box, Bangladesh and nearest regions shows around 20 millimeter of precipitation, and northern part of India shows average 100 millimeter precipitation over the period. The analysis of relative vorticity at mainly 700 and 300 HP level shows that the northern part of Bangladesh is positive vorticity, and which is important criteria for WDS. At the 4 pressure levels of geopotential height 850 and 700 and 850 and 700 levels, HP levels, northern part of Bangladesh and India, in northern part of Bangladesh and India shows the lower scale of geopotential height, which is also indicator of winter rain due to WDS. When we have analyzed the wind speed and direction during the winter months, we have seen that usually wind is northwesterly, and usually wind, you can see the direction of wind is northwesterly at 850 and 700 HPA, while it is westerly over the 500 and 300 HPA level with a very high speed at around 45 meters per second over Bangladesh. We have also analyzed the monthly behavior of relevant WDS parameters. Here we have seen almost similar pattern, the parameters as the previous winter months, analyzing, and we can see at February. And at February, it is higher and greater March precipitation than December and January. And in in December and January, Bangladesh get around 10 millimeter rainfall on average. Here we have analyzed the month-wise distribution of geopotential height, and it's got the similar pattern. We have also analyzed monthly relative vorticity at 300, 500, 785 HPA level, and it is also same than before, and is shown the positive vorticity. As an example, I have chosen a case from anomaly table. I said before, the 5 days accumulation of model simulation during 2 to 7 January 2020 is found 75 millimeter of rain. And the ERA 5 and IMD data is equally same, and it is about to have 50 millimeter rain, and the model, and you can see the model overestimated the ERA 5 and IMD data. The different parameters at the event is shown at 3 HP level because it's very significant to the case. And from day 1 to day 5, it has been showing the propagation of western disturbance from westerly. And at the day of 3, it has been moving over Bangladesh when the wind speed was high and vorticity was positive and upper trough over Bangladesh. In the present study, the climatological behavior WDS reveals that during winter, Bangladesh receives significant amount of rainfall, and it's about 20 millimeter, and cyclonic circulation along with westerly trough has been observed at 300 HP level over the northern part of Bangladesh, and positive vorticity is also seen over the regions and that have received rainfall eventually. For model simulation, I have used NSSL2 as microphysics scheme and grade 3D as cumulus scheme, and have been chosen for comparing the root mean square error. And the model performance is found reasonably well. And thank you.
Okay. Thank you. Thank you for your presentation. We are much before in time, actually. Really, still we have half an hour to go. But if any presentation is left or anybody want to present again or anything, I mean, welcome. Or then otherwise we'll go to question answer. Dr. Mohammad Shah Kamal, co-chair, has also joined. So I think we can go for question answer. If you have any question, we are really, I mean, interesting talks. So I welcome all to
Dr. Melin. Yeah, thank you for conducting this session. Actually, you know that this session is designed for our students only. So they're conducting research as part of their master's program.
Yes.
So I will expect some questions from you and critical review on their work. So this session should be more interactive. And I'd like to invite all audience actually to comment on their paper.
Right. We'll have our comments at the end, but before we give the comment, I would really welcome all nice presentations. And yes. So if not, then we can go ahead with the summary of this. We can. The first presentation by Dr. Nachiketa Acharya.
Dr. Milind, sir,
Yeah.
I think Dr. Terao has raised his hand.
Yeah. Please go ahead, Professor Terao-san. Please go ahead.
Good morning and good afternoon now. Yeah, and so thank you for the very young researchers now presented their talks. It's very fascinating for me, and so it's very nice researchers now going the new commerce now growing so much, and it's very happy to us. And I have one question to looked up Mr. Mohammed Saifur Rahman. So he presented about the
Yes.
The climate change on the agriculture.
Yes.
And so maybe I sort of missed your talk some part, but you told about the water requirement in reducing in the future. So maybe I missed some slide. So what is the reason why the water requirement decreased because of the global warming? So why? So it can be estimated with some data set.
Well, I cannot hear the question because my net connectivity is weak here. Can you please repeat the question, please?
Okay. In this slide also you told about that the decreasing trend in future the water requirement, crop water requirement.
GG. Yes.
Second, so it is somewhat very difficult to understand because sometimes the temperature going up, then at that time the dry up because of the evaporation. But you estimated that the water requirement will reduce. So it is, they can get much water from the precipitation.
Okay. Now I understand. Because of the increasing trend in temperature, if I show you the graph, because of the increasing trend of temperature, we find that the growing days of rice is reduced. Normally, the growing days is 145 days, but it reduced up to 38 days for extreme scenario, that is SSP 585. So that 38 days crop water requirement is not required for those who's already established their or complete their life cycle before 38 days. So in that sense, that the total crop water requirement in that particular Bodo season is decreasing.
That is good. So what it is somewhat based on some some basement about the water using by that crop. And so when the crop growing quicker, sometimes so the water requirement for that crop also the same, or it can be increased, or is there any change about that the crop development is higher, then they may use much more water for that.
Yeah, actually, the growing duration is decreased, and the production is also decreased. If you see that these graphs, and I already told earlier for SSP 585, nearly 2,500 kg per hectare grain yield is reduced. So with the decreasing growth days, the yield is also reduced, but or we can say the grain yield is also reduced. So in the broader aspects or combined effect, that crop water requirement for this in this Bodo season is in a decreasing trend. We found that.
I see. So somewhat complicated. So if the change the temperature.
Yes.
Okay, understand. It's very interesting estimate. So I'd like to listen to your next expected presentation in the next time chances. Thank you.
Okay. Thank you.
Can I make a supplement?
Yeah, please. Please.
Dr. Taro raised a nice question, and this is an interesting finding also. But here in the paper, we are talking about the seasonal crop water requirement. That is not the daily or annual crop water requirement. Of course, if the temperature it rise, then crop evapotranspiration will increase, and that is if we consider the total water requirement or annual crop water requirement, then it will, of course, it will increase over the time due to the climate change. But what Saipur is try to talking that with the increasing temperature, that will cover the more GDD, growing degree days by the crop, and that is why it will mature earlier than the usual time. At present, the cultivar Breathe 20 is maturing in Mymensingh region by 145 days. But if the temperature will rise by 1 or 2 degrees centigrade, then what will happen? The crop growth field duration will reduce. So that will what will happen, the increasing temperature per day crop water requirement or evapotranspiration rate will increase, but the combined effect of increasing temperature and the reduced growth duration will ultimately reduce the crop water requirement than the usual. So that is one of the factor. And what will happen if the growth duration reduces? It will affect negatively the crop yield. And that what he is trying to mention, that we have there is a great scope for the breeder, so they have tried to develop the cultivar with more heat tolerant in future. So thank you. Your question was really nice.
Yes, so interesting. So
and for one information is that we have did several crop modeling process, and we found that if the temperature rise by 1 degree in Bangladesh, then the crop growth duration will reduce by 7 or 8 days. So we are projecting in SSP 245 and 245 that the temperature will rise by 3 degrees and near about 3 degrees centigrade at the end of the century. So the growth duration will reduce by 21 days. So that is a great alarming for us. And I think the breeder should have taken the challenge to develop new varieties. Thank you.
I understand so much. Yes, interesting.
Thank you. So here another, just to, this thing, the evaporation will also decrease with the temperature rise. The evaporation decrease.
This evapotranspiration, we calculate the evapotranspiration. Evapotranspiration will decrease total evapotranspiration by the crop, by that particular crop. But the daily evapotranspiration of seasonal or monthly or annual evapotranspiration will increase due to the effect of rising temperature. But what will happen if the temperature will rise and the sunshine hour or solar radiation will decrease? Then there will need mass consideration, because if the current trend of solar radiation is decreasing in our country, so that is the negative effect on evapotranspiration rate. If the solar radiation decreases, the evapotranspiration rate will decrease. So we need to analyze the combined effect of all the climate parameters to estimate the crop water requirement or evapotranspiration.
And that may also lead to this, the reduction in the growing period. Maybe, that may be one of the reason. Why the crop yield is the total grain yield is reducing.
Yeah, that is the alarming. So
Thank you so
that's
much.
so that's why we have to search up for the long duration cultivar in future, because the growth duration of long duration cultivar, that will also reduce, but that will give at least higher yield than the present cultivar, I think.
Yeah. Any more question? Other. So if we go through this, I mean, I will go in reverse order. This climatology of Western disturbances. Very nice presentation by Munmun Akhtar. And the thing is, yeah. So the thing is, I mean, only what I want to say is this is Western disturbances. It is difficult to I mean put in terms of this mid-tropospheric cyclonic circulation. This also extends from in the upper troposphere. There are a lot of, I mean, if you see this Mausam publication, Pisharotti and Desai, 1956, then Kalsi Haldar 1992. Main thing is you may come across this, the baroclinicity of this subtropical westerly winds. This how this evolves, or what is the main mechanism behind this. So unless until you bring, because it extend not only to, I mean, from mid troposphere to upper troposphere. So and also the same way when it propagates, it extends down to lower atmospheric levels also. So those things are to be, because see, when you say that, I mean, for a monsoon, see during the monsoon season, we have mid-tropospheric cyclone during the monsoon season. These are typically I mean non-monsoonal systems, what you are talking, I think, and definitely these are mid-latitude evolving system, very interesting, and it has a really good you need to have the good assessment of these systems. I mean, how it will have, and it is the synoptic scale systems. Again, the thing is, it is not just I mean mesoscale system. It is beyond that. So those things are to be. I mean, how this the air mass rises. I mean, the rise of the air mass above this mid-tropospheric level. Those things are to be brought out, I think. But it was overall, the presentation was really good. And maybe with the observational data, if you can put in that, will be more interesting. So thank you. Yeah, thank you. You may look into some other. I mean, Madhura Ranade also from our Center for Climate Change Research, IITM, had published paper in climate dynamics during 2015. And you may see some inferences, I mean, references from that, and the mechanism also. So that will be more interesting. So this is
our research is further.
Yeah, good, excellent. I wish you all the best. Excellent. Lisa Parvin, I mean, this was her topic was sealing irrigation advisory system, IRAS, nationally, and developing messaging system for integrating IRAS advisories within BAMIS. So she could not present, I think, I mean, because of her health issue, something. And yes, the another presentation was this ICC 24, change in crop water requirement and yield of boro rice in Mymensingh under future climate condition. Very nice presentation, nice discussion. Professor Toru-san also asked good questions on that. And I mean, boro rice and boro season. I mean, first time I came to know the boro season from November to April it is actually. And this CMIP6, I just want to have this thing, this selection of CMIP6 models on
Yes,
I mean, what is the criteria you have put on? Yeah,
I have go through some literature review over those are over Bangladesh for different variables, and I choose 5 models. Models for the best fit, and then I do the validation work for from 2015 to 2020. Validation work, which model is much correlated to the observed data, and then for 5 variables, which model is more correlated and more less biased. And then we calculated the ensemble mean of the 5 models, and then we find out that the ensemble data of those 5 selected models are showing the less percent bias and more correlated to the observed data. So this future crop modeling weather file is created with the ensemble mean or ensemble data of these 5 models.
So have you done some uncertainty analysis, uncertainty estimates?
Uncertainty analysis not done yet, but this is the ongoing research. It will be.
Yeah, that will be good. I think. I mean, then that will really strengthen the scientific credentials. And another thing is while selecting, have you used the Taylor diagram analysis or analysis?
Actually, when I go through the literature review, those paper is also already did those analysis, and I for this purpose or for my thesis, I rely on them. I didn't do it myself, but for the further use, I will take action for this.
Yeah. You may just learn, and you may include it also. That will be really that will be useful. And then you have to also see just not the rainfall precipitation. Bias, but how it is more suitable for your crop modeling activities. So maybe yes, you have included the parameters. Whatever variables whatever variables you have taken from that. So that you have definitely, but others may be more interested in rainfall simply, but you may have more constraint on you may like to go for soil moisture also, or other variables, related variables, which may be useful for this thing. Thank you so much.
Thank you.
Nice presentation.
Thank you so much.
Then was this 23 ICC 23. Characteristics of severe local convective storms observed by Doppler weather radar and their simulations using cloud resolving scale model over Bangladesh. Yeah, it was a really nice study, and is extensive work. Of course, Professor Someshwar Das is there. Dr. Fatima Akhtar is there. Yes. They have done a lot of work on this. Yesterday, very nice discussion Professor Someshwar Das had on this and this severe thunderstorm, STS, whatever this northwesters. So what study is done using WRF model, particularly this the bias and RMSE. You have taken care. Rehan Mohammad Chaudhary. So this was really good study. Only the thing is this the mechanism, again the mechanism, maybe how this threshold reflectivity could be more useful in getting insight into these systems, maybe really useful. Very interesting study. And definitely Professor Someshwar Das, he is the authority actually. So to speak about this and is guiding this, I'm sure it will have much more clarity, and it will advance very well this study with the more confidence in simulating these events using the particularly this Doppler radar data. So that is very important. You have very good observational evidences, and the very high resolution WRF you can simulate it. Then 2022 this 22 this collection, quality control, and curation of ground data for continued development of satellite-based crop area monitoring system for Bangladesh by Mohammad Afzal Hussain. Yes, this crop area monitoring, what he had decided, I mean, he has given the the summary about this thing, the plan of his study in crop area monitoring, crop phenology, and crop type identification. Yes, we look forward for his extensive study on this with Dr. Saurav Dey and Dr. Shah Kamal Khan. How this evolves. Thank you so much for a nice presentation. Then assessing this future drought characteristics in Bangladesh using bias corrected CMIP6 by Sabista Yildiz. A very nice study. Her analysis, I really like the analysis, what she had done, extensive analysis, and particularly the for frequency, distribution, duration, and severity. How this frequency, duration, and severity is changing in this climate assessment. That's why I shared, and all the indices what she has done very extensive. This drought indices what she has done, that is also very nice. Nicely she has analyzed this and come up with for different periods, near future, mid future, and far future. So those things are and for different scenarios, SSP 2 4.5 and SSP 5 8.5. So the similar thing, I mean, that's why I shared the book, our open access book on assessment of climate change over Indian region. So that is very nice this thing study. Only the thing is observations, how the observational evidences more can be involved. That will really strengthen, and particularly the duration period. I mean, how the duration of these droughts, the long duration droughts, how they will influence. That is a major concern. I think 6 months she has brought out more than this. So yes, these indices also, SPI and other indices, will definitely, I mean, will throw light on this, the changes of these droughts. Frequency, duration, and severity, how this will be affected, and the main again and again this your level of confidence. What you need to really assess is again the confidence level, how confident you are. Uncertainty analysis is also equally important. Maybe, I mean, that will strengthen the study, the bias, and limitations also, whatever the limitations. Finally, yes. Dr. Needless to say this, Dr. Nachiket Acharya, excellent presentation. I mean, I have no words to express my feeling. Actually, very nicely, how nicely, and this is the really ideal presentation we should follow. How the systematically things are presented, put, and the review is also presented, and the due respect is given to the past and current studies, and what is the limitation. Main thing is, I really like that the limitation of the study, and very importantly the variability. Indian summer monsoon or this South Asian summer monsoon, the main thing is the variability. That the variability amplitude is very less. What is said is absolutely right. I mean, there is very low, I mean, less scope in defining those things. But the main thing what we see here is, importantly, how still, I mean, given all the limitation on seasonal scale, and again the thing is, I mean, on seasonal scale, the frequency, the duration, and severity, again these parameters, how we can bring it, and how to in hybrid mode, that is also very important. I mean, yes, that is the how to use the model, why to use the model, and how well you can design those experiments. Model may have a lot of uncertainty, model may have different problems, model may not be actually, whole thing may not be, may not give the realistic picture, but how you extract the realistic information from the model, that is really, I appreciate that. And a lot of analysis also what he had presented, multi-collinearity problem and other things what he did this present, that is really remarkable. And maybe even students and many of us can take a good note of those things, how this seasonal prediction and the seasonal, what is the importance of this seasonal prediction of tropical cyclones in Bay of Bengal, and how these whole the previous studies have brought out the predictors and concurrent predictors, and this using this GCM, all this in output, whatever simulation, how to then put it in probabilistic manner, how to use that in, how to present it in probabilistic manner, that is really remarkable. I mean, that is how we can see, and then it's a validation also, how successful we are, how confident we are. Very, very important is this how this will evolve. I mean, one thing is the genesis, how the genesis and all other this thing is, but that is a matter of on different scale. But when we go to seasonal scale, what is this actually, how this gradient will large scale forcing, I mean, this IOD, and so all these forcings, I mean, regional and remote forcings, how they will influence these cyclones. I mean, two things are there. One thing is the cyclones which evolves in the Bay of Bengal itself, to originate in the Bay of Bengal, and another thing is which are, I mean, which are part of this easterly wave components of from evolving from the wave propagating from northwest, this Western Pacific or South China Sea particularly. So those things are really very critical. I mean, these things are very linked to, so it has regional as well as the remote boundary forcing influence. And to simulate those things and to deduce information to how to do that, that is also really very, thank you, Dr. Nachiket Acharya. Thank you so much. So I think I have to say this, this is a very successful session from all the young researchers, and this is, yes, we need to have this young engaging youth in climate science. Thank you so much. So I welcome co-chair, respected co-chair, Mohammad Shah Kamal, if he has any comment. Thank you, sir. I am done from my side. So Toru-san, you have any question, anything?
No, just a clap hands for you.
Yeah, thank you.
Thank you.
Okay, thank you for giving me the opportunity. It's my great pleasure to join co-chair of this session today. Actually, I'm out of Dhaka. Even then I joined.
Oh, great. Thank you. Thank you.
Actually,
thank you so much.
In fact, we do believe that education, research, and extension are very much correlated to each other.
Yeah.
And nobody, gets success with the linkage of each other. We do believe it.
Yeah.
And considering that situation, we, the Department of Agriculture Extension, works with different academic institutions like Dhaka University, Bangladesh Agriculture University, Bangladesh Sheikh Mujibur Rahman Agriculture University.
Yeah.
And we do work with the different research institutions like Bangladesh Rice Research Institute, Jute Research Institute, Sugar Cane Research Institute, Agriculture Research Institute.
Mm-hmm.
And along with the findings, we take action from our side, and people are getting benefit from that. And climate is changing. It is very prominent, and we do believe that all together should take action to accommodate, to mitigate and adaptation to the climate change. And especially being an agriculturist, I should say, climate smart agriculture need to be ensured for, sustainability of agriculture, production, and the yield in our country. And in that context, agrometeorological research is very important. And I highly appreciate the meteorological department, headed by Tovida Madam.
Yes.
And she started different types of research on agrometeorology. That is very important for our country. And if we take action based on the research findings, obviously Bangladesh will get benefit. Let me tell, I highly appreciate all the presenters for their nice research work and their findings. The presentation, that is very excellent.
Yes,
I should say it will give good impact in aspect of agrometeorology, especially I should say the different weather parameters, response to different crop stages, yield, and different aspects of crop and agriculture. That is very much distinct, and they have found very good observations. And especially I would like to tell the Afzal's presentation. That is also awesome, I should say. Crop estimation is very important.
Yeah.
Planning, policy making, and taking action for agricultural development, it is very important. But nowadays, I should say till today, we are based on the eye estimation of our field level officials in Department of Agriculture Extension. If we could shift to the satellite-based monitoring system of crop, then our policymakers, we, the people work on agriculture development, that will give a good, impact on national level, I should say. Though it is just a MS level research, but I should say it has a good prospect in our country, and our government can take special attention to use such kind of important tools. So all the presenters have done fine. I personally acknowledge and appreciate their presentations. And in future, obviously, such kind of research work will be continued. And from my side, any kind of cooperation, any kind of support will be provided as such. And again, I thanks and acknowledge to Tovida Madam, Head and Chairman of the Department of Meteorology,
thank you,
actually, who has initiated such kind of agrometeorology research work. And I am a co-supervisor of 2 research MSc students. This year and last year, I was for 1 student. So such kind of coordination is very important to, improvement in agrometeorology. And I would like to tell another thing is that under my project, we have already opened Department of Agrometeorology in Bangladesh Agriculture University and the Bangabandhu Sheikh Mujibur Rahman Agriculture University. They are also going to enroll MSc students on agrometeorology. So that will be another chapter opening in our country.
Great.
So thank you so much, sir, for giving me this opportunity, and thank you all.
Thank you. Thank you so much. I echo co-chair actually, Dr. Mohammad Shah Kamal. And definitely, I mean, it is all the great efforts of Professor Dr. Tohida Rashid and Saurabh. They have been always after this, and they have done a wonderful job. And this is a good platform they have provided for young researchers. And every year I have been connected with this international climate change conference activity for last 3 years, and we have been presenting. And our team is also now getting associated with this. Definitely, we would look forward for more and more better presentations. Good future. Thank you so much. So kind of you. I am also really thankful. I mean, I told in the beginning, I may not be able to do justice to the chairmanship what Professor Dr. Rathod Saab might have done. but given the opportunity, I have tried my level best to perform this duty. Thank you so much. Thank you. See you. Thank you. Bye. Thank you, Toru-san. Thank you. Thank you. Thank you, Saurabh.
Thank you, Dr. Milind sir, for nicely chairing the session. And thank you also to Dr. Kamal sir for joining. I mean, he's out of Dhaka. And so thank you to the presenters for presenting their ideas.